Is EGB congruent to angle EFH? EGD is this angle, and EFH is this angle. I'm not going to leave those marked on there, but I do want to point out what we're trying to prove here. Looking at the fact that DE is congruent to HE, and that was given by the picture, we know that triangle DEH is an isosceles triangle And if you wanted to write down that was a definition of an isosceles triangle, you could, but we're going kind of in it with an informal proof here. And because it's an isosceles triangle, then we can jump to the conclusion that this angle and this angle are congruent. Because angle EDH is congruent to angle EHD, and those are base angles of an isosceles triangle. So now I can make the statement that triangle EDF is congruent to triangle EHG, and because of side angle side congruency theorem. So I just said that that triangle and that triangle are congruent. Using that information, I can say that EF is congruent to EG because those are part of the same triangle, so that's CPCTC. Corresponding parts of congruent triangles are congruent. I can also say that triangle, let me switch colors, triangle EFG is isosceles, and that is definition of isosceles. Triangles. So then we can jump to the next conclusion, which is that this angle and this angle are congruent, which is what we were looking for. Angle EGD is congruent to angle EFH because those are base angles of an isosceles triangle. Sometimes isosceles triangle, or you could say that that is the isosceles or base angles theorem. Go ahead and pause your video and do the try it and come back to check your work when you're done. Okay, we're going to look at the fact that this triangle right here has congruent base angles. Because it has congruent base angles, then we know it's isosceles, and that means that that piece is congruent to that piece. I also see that this pair of vertical angles is congruent, which means that this triangle and this triangle are congruent by angle side angle. And since those two triangles are congruent by angle, side, angle, then we know that this piece and this piece have to be congruent by CPCTC. There are about 4 other ways you could have figured this out. So if you did a different way, you really should have still come out with the fact that W or VW is congruent to ZY by CPCTC. I used triangles WXV being congruent to triangle YXZ by side or by angle, side, angle. You could have used these big triangles right here, but in the end, that's what you're looking at.